Hello everyone, this is Naitik and today we are going to do decimal expansion. So this is not a new topic, but yeah, this is a new topic for you. Just the name has changed. Nothing else is new over here. Just you have to divide, and the thing which you will get is the decimal expansion of that number or that rational number or real number or anything. So first, let us do what? The definition of decimal expansion. So no need of the definition. I'll just write what do you mean by decimal expansion. So for example, you have any number, let's say x. Yes, so you have any number x and you divide this x by any number y. Okay, so how will you write this? Something like, if you divide 10 upon 3. So let me just write it not this way. Let me just write it like, you do x upon y. Okay, so you do it like this. Okay, if the question is very big, you do it like this, and the answer you get over here. And when you do all this, and the thing which you get over here, let's say you get z over here. So this is what? This is the divisor, right? This is divisor. And what is this? This is dividend. Dividend. And let's say over here you get P. Okay, so this is the quotient. Or I'm just going to write like Q, and like it's important to write this, so that's why I'm writing these two as full. This and this I'm writing it full because otherwise you won't be able to know. And this is known as the remainder R. So P, R, D and D. Okay, so something like this you have the thing. So over here, the quotient which you get, this will be the expansion of the number. Expansion will be this. So the quotient will be the expansion, and you know the remainder, right? So now let us do these questions. This is example number 5. So let us do these. I'm just going to take, let's say, yellow color. Yeah. So as I said, we will do like this. Okay, I'm putting the laser over here so that you can see. So we'll do like this, x upon y. So it is written 10 upon 3. Now we'll convert it to this. So 3 is dividing 10. So we'll write 3 over here. On the left side we'll write 3. So let me just write 3 over here. 3. And then you divide this 3, or let me just make it like this. You divide this 3 by 10, right? So 10 will be over here. And then you do like this. That's not good. So let me just this. So 10 over here, and now we'll solve it. So 3 2s is 9. So we'll subtract 9, which will be 1. Now we'll put a decimal over here and take 1 0 extra. No need to tell because this we have already done in previous classes. So now again this will be 3. Oh my god, I did a mistake. 1 second. So we'll subtract 3 and this will be 3, not 2. 3 2 is 6. So now you get 1, then 0, then again 3, minus 9, again 1. So let me just write it straight. Again 1 you will get, and after it you again write 0 and this will go on further. So 3.3. This will keep on going. 3.333. Okay. Now let me just draw a line over here and I am doing the next one. Just like this. Now I'm doing the next question over on the right side. So over here you know the answer, right? Over here you know the answer. The answer you got. Let me just switch to another color. This is the answer. Okay. So, and this is what? The divisor, dividend, quotient, remainder. Okay. So this is the answer for this. So let me just write 10 upon 3 will be equal to 3.3 ... Okay, because this will keep on going. Now let me just switch back to the color, and now I'm going to do the next one, which is 7 upon 8. So how will you do this? Very easy. Again, just write 7 over here, divide it like this. Oh, that's too big for this. So I'm just going to do like this. 8 over here, and then we just close it. This is not looking that good, so I'm just making a rectangular one. This is 8 over here, and now this will be the question on the right side. So 7 ones are 7. Oh no, I did it the wrong way. 1 second. So you get 8 over here, then you get 7 over here, then the question will be on the right side. So you know that 7 does not come in the table of 8. It is less than 8 ones are 8. So what we will do? We will put a 0 over here. Okay, so first we didn't count the first letter of the first number, so we didn't count it, so we write 0 over here. So 0 and point, because of this 0 we will write a point. Okay, now we will subtract what? See, over here if you don't remember the table that good, you will take time, or like if you see 8 9s are is 72, and just before it 8 8s are 64. So I'm just going to write 8. You can do like this, hit and try, or if you remember that fluently, you can go with it. So now minus 64, what you will get? So 70 minus 64, you will remain with 6. Not divisible. Again 0, because after points you can put as 1 0 in each case. So minus 8 7s are 50 what? So like over here, I am just going to tell one more thing. Just wait a second. So over here in the previous one, if you see this like 3.3 ... So it can also mean that 3 point after 3, this 3 after this 3, it can be 1 2 7 so on, but in this case it is one more 3. So let me just write one more 3 other, so that it is clear to you, right? So now it will keep on going like 3 3 3 3 3 3 and so on. So let us get back to the question. Yeah, so this is, where were we? So 8 64, you remain with 6, then you can subtract it, then you get a 0 minus 5, and yeah, 8 7s are 56. Then you again divide it, you get 4 40, and I forgot to write 7 over here, and 8 5s are is 40. You minus 40, and there you got the answer. So the answer over here is like 7 upon 8 is equals to 0.875. So this is the answer again. Now over here you all know that divisor, dividend question, and this is the belowest part is remainder. So now let us get to the next question, which is, oh my god, I forgot to see the question. Yeah, 1 upon 7. Oh, this is the previous slide. And there we go. So let us do 1 upon 7. Yeah, I was picking yellow color. So 1 divided by, so 1 upon 7, we write 7 over here and 1 over in between these brackets. 1 is less than 7, so we'll add a 0. So and this will be 0 point now. Minus 7, because 7 ones are 7, so I'm going to write 1 over here. Then you get 3. Then you will add 1 0. Then 7 fours are is 28. Minus 28, you get 2 and 20. And 7 twos are, then you minus 14. What you are left with 6. Then you add a 0, and let me just increase this a bit more. Yeah, then you subtract 8 because it will be 56. Then again you are left with 40, and after this what you will do is you will subtract 7 5s are minus 35, and this will be left with 5 and 0, and then you will subtract 49 because 7 7s are 49, like 7 over here. You subtract 49, and oh my god, the space is less, so you subtract 49. I'm doing this over up here, so let me just make a line over here with white. Yeah, so now I'm going to do it over here. Hope it's good with you all. Okay, don't understand that this is something else, this is the same. So now you are left with 1, right? 10, 7 1s are 7, minus 7. Then again you are left with 3, 0 minus 28, and again you are left with 2, 0, and yeah, that will go on because it will repeat once again. Don't believe me? You do it again. 1, 4, 2, 8, 5, 7 will repeat it once again. So I'm just going to do dot dot dot. Okay, so if you find that something is repeating again and again, do this dot 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 dot. Okay, so now I have, let me just take blue color pen. 1 upon 7 is equal to 0.1428527 1428 or 2 dot dot dot. Okay, so this is the answer. Pretty long, but yeah, you have to do this. So the next thing which we are doing is what? So let me just take the next page. Yeah, next thing which we are doing is nothing but types of decimal expansion. So we are doing the types in on the slide we'll do the types. So what are the types of decimal expansion? So let me just take red color pen because this is very important, because if you remember this, like half of the chapter is done, almost the half of the chapter, or 1/4 of the chapter is done if you remember this. So there are 2 types, not actually 2. First, let me just what all real numbers contain. Real numbers contain 2 types of numbers, rational numbers and irrational numbers. So let me just write over here, for rational rational or let me just write everything in capital. Rational numbers. Okay, so now we have rational numbers over here. So on this whole slide I'll do rational numbers. So let me just write. Okay, so now let us start with it. So rational numbers are numbers which can be written in the form of p. Oh yeah, sorry, my pen just fell down. So the numbers which can be written in the form of p upon q, where p and q are integers and q is not equal to 0. So let me just write down. It can be written in the form of p upon q. You all know this, right? This is the by-hearted definition we know. So now the first type of decimal expansion which rational numbers have. So I just told you what are rational numbers in the previous slide. What is decimal expansion in the previous slides and how to divide and all. So decimal expansion is if you divide any two numbers and you get the answer, that is the expanded form of it. That's the decimal expansion of that rational numbers or irrational number. So let me now take that. It is over here. Let's say over here. First type of decimal expansion of rational number. You have to remember this. There's no trick or something which I can tell you so that you can understand it. But you have to remember this one. So the first type of decimal expansion is what? Terminating. You'll be like, what is terminating? Right? I know. So let me just tell you. Wait. Or yeah. Terminating. What is terminating? Nothing difficult. To terminate, it means to I got a trick over here. Terminate means to end. Okay? Terminate means to end. And end of some, if we are dividing, and end in dividing means, let me just take yellow color pen. End in dividing, or let me just take this one. Yeah, end in dividing is nothing but 0. And when you get 0 in the what? Remainder. So when the remainder is 0, when the remainder is 0, it means the type of decimal expansion is terminating. Okay? Really easy to remember this. So now let me just take an example of it. So terminating means, let me just write down a type of definition over here. Terminating. For example, I have any number. Let's say 2 upon 4. This will be equal to 1 upon 2 because 2 1s are and 2 2s are. Okay? 1 upon 2. So if we divide 1 by 2, this will be 10. So 0 point and 2 5s is 10. So minus 10. 0. Remainder is 0. This is terminating because it has come to an end. The answer is 0.5 and it is not going ahead. Yeah. So if you have any decimal number or anything which you divide and solve, or it is already solved and it is not going on further, it is ending. So over here, let me just erase this. It is not going further. It is ended. Okay. We don't have to put dot. Just trick, you don't have to put dot, terminating. Okay? So this was terminating. Let's go on to the second one, which is non-terminating. Let me just write non-terminating. Non-terminating it is non-terminating, but it is recurring. So let me just write, instead of recurring, let me just write repeating. Okay, or let me just write recurring only, because in the book it is given recurring. Non-terminating, recurring. So what is this? So terminating, you know, when the remainder is 0, it is terminating. Now if the remainder is not 0, you have to put dot 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 dot. Okay, you have to put that dot dot dot. That means it is non-terminating. So this part is done. Now let us go on to the second part, which is recurring. This part. So in this part, now recurring means repeating. Okay, so if something is repeating, it is going again and again. So 1 1 1 1 1 1 1. Okay, so this is repeating, right? You all know. So now if it is repeating and it is non-terminating, it is also a rational number. Okay, so these two, if these two type of decimal expansion are there, it means the number is a rational number. So now let us take an example of this one also. Let me just take this toolbar thing upside. Okay, so now if thing is not terminating, means r is not 0. Let me just write over here because it will be easier to remember. R is not equal to 0. Okay, remainder is not 0. Or let me just write, once again, it keeps on going dot 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 dot, repeating, you know, like 1 2 1 2 1 2 dot dot dot. So that's repeating. So let me just take one example. So let me just go 2 slides back. You have 10 upon 3. Okay, now over here the answer was 3.33. Okay, just like, let me just go next slide. So as you saw, the answer which we were getting in 10 upon 3 was equal to 3.333333, so on. So you know, repeating dot dot dot, it is non-terminating, repeating, and it is also a rational number. So these two types of decimal expansion, if they are there, it means the number is a rational number. Okay, so let me just do one thing over here, which is, let me just take another example. So for example, you have a number as, this is another example, let's take one more. You have a number as 0.1717, and or let me just write it on the left side because over here will be my face also. So another number is 0.1732, or instead of this is also an example. Let me just go slide back. This number, like 1 upon 7, it was 142857. Okay, so let me just go a slide ahead. Question was 1 upon 7, 0.142857, and dot dot dot. So now one more thing which I forgot to tell was, you can write this as 3. You have this number 3 point, and the number or the numbers which are repeating, put a bar on that, put a straight line on that, and then you can write it in the short form. So over here 3 is repeating again and again. So you write 3 and put a bar on it. This is also an example of representing. Over here you can write 0.142857 and bar on this hole. Both are correct. This can be also come in the question. Okay, so if you have to convert this in the form of PYQ, we'll do that. No need to worry. We'll do that if this comes in the question. So you can do like this. It can come like express 3.3 bar in the form of PYQ. So this can also come. You don't have to write dot and repeat it again and again. You can write it like this. And yeah, that was all. In the next video we'll do the decimal expansion for irrational numbers. Otherwise, if I am doing this in this video only, then it will be too long. So in the next video we'll do irrational numbers, and also we'll do what? Yeah, I'll think of it. So we'll do decimal expansion for irrational numbers and also how to express in the form of P by Q. Okay, so yeah, I think that's it for this video, and we'll do something in the next video. Till then, bye. Have a great day.